Bismillahirrahmanirrahim. Assalamu alaikum dear students. So we are now starting the second lecture for the course of communication systems. In our first lecture, we talked about some fundamental concepts regarding communication systems. Specifically, we discussed why we use communication system, because we want to carry the information over a longer distances. So these electronic circuitry, they form a communication system to help us carry our information to a longer distance. Secondly, we defined some fundamental terms related to communication system, which are information, message, and signals. And we also defined the types of communication systems, analog and digital communication systems. So now let us move on to the basic structure or basic block diagram of a communication system. So generally a communication system has three major elements which are illustrated in the block diagram here. The first one is the transmitter. Actually, transmitter performs certain functions in order to transmit the signal to a longer distance. The information is generated by a source which has to be taken to a longer distances. So basically this information becomes an input signal to the communication system. So this part here is actually our communication system. So the first portion is transmitter. The first thing that is done by transmitter is to transform the information from the source into an electrical form. It performs the function of transducer. Secondly, it makes certain changes in that signal, and these changes are made in such a way that the communication system, the signal becomes suitable for transmission. So after the changes are made, the signal is transmitted over a certain medium which is named as transmission channel. So the signal would be received at the receiver side, and receiver actually undo what was done at the transmitter side. So it reverses all the actions that were taken at the transmitter in order to recover the original form of information. So after the original form of information is recovered, we get an output signal which is delivered to the destination. While propagating in communication system, there are certain phenomena which affect the signal propagation, which is illustrated here as noise, interference, and distortion. So let us now individually discuss each part of the communication system. So the first part is the information source. Actually, information source is actually any source which originates the information or message. It can be a human voice, it can be a television picture, or any type of data. In some cases, although the source generates the signal in electrical form, but in other cases the signal is in non-electrical form, so we need to use our input transducer in order to convert that signal into an electrical waveform. So the electrical waveform that we get from this input transducers is generally named as a baseband signal or a message signal, or okay. So after the information is converted into an electrical form, it goes through a transmitter. Transmitter actually tries to change that baseband signal in such a way that the overall efficiency of the transmission is increased. So it makes certain changes in the signal, which we will be discussing later, and those changes are made in such a way that the overall transmission quality becomes higher as the signal becomes more suitable for the transmission. Generally, this transmitter consists of many subsystems and components, and those systems are pre-emphasizer, sampler, quantizer, transducers, amplifier, modulator, oscillator, power amplifier, and antenna. These are the names of few subsystems that are used in a transmitter. So basically, transmitter is collection of all these components which perform certain operations to the signal. The next entity in the element in the communication system is the transmission channel. The word channel or transmission channel or communication channel, we use all these terms to identify the transmission channel. This is actually the main part of the communication system which carries actual system to a longer distance. So this channel is actually the medium which actually takes the output from the transmitter and delivers it to the receiver side. So this medium can be of variety of different types. We have encountered different types of medium in the normal day communication systems. You can see a copper wire, the traditional telephone line that comes in our home. The landline telephone line is actually a pair of copper wires that is used as a medium to carry the signal from one place to another place. The coaxial cable that is commonly used by the cable operators to send the transmitter the TV signals to our homes. So this is also a type of medium which carries the signal uh, uh, from the transmitter side to the receiver side. An optical fiber, which is generally used in computer networks, is also a type of medium or a channel which takes the signal from transmitter to the receiver. For a radio link, like the wireless channels that we use for the mobile communication, is also a type of channel. So we have different types of channels uh, which which can carry the signal from one place to another. So based on the type of the medium that we use in our communication systems, so we divide our communication systems into two major categories. One is a wireline communication system and the other is a wireless communication system. A wireline communication system is that where we have a dedicated line which is connecting the transmitter to the receiver. For example, the copper wire or a coaxial cable that is used to carry the information from one point to another point is a type of a wireline communication system. Actually, for this course we will be focusing on the wireline communication system, but there are certain applications where we do not use a dedicated material to carry the signal, and we rather transmit our signal through the air or through free space. So in such cases the system is named as wireless communication system. Like the mobile phones that we use or satellite communications that we use, they are the examples of those wireless communication systems where we do not have a physically connected lines between transmitter and receiver, rather the signal goes through the air. As I said, for this particular course of communication system we'll be focusing on wireless communication system, and we have a dedicated course on wireless communication systems in our next semester. The important thing is that whenever the signal passes through a communication channel, there are certain phenomena which affect the signal quality, or which affect the propagation of the signal. So because of those channel impairments, we generally the signal quality degrades and results in information loss. So there are certain types of those impairments that will be discussing later in today's lecture. The next component is the receiver. Receiver is actually collects the signal from the transmission channel and then it tries to recover the original form of the waveform that was used to represent the message, and it tries to undo whatever modification was done at the transmitter side, because as I said, at the transmitter make certain changes in the signal to make it suitable for transmission. But of course, in the original form, we do not want those changes, so receiver is designed in such a way that it reverses all the actions that were taken at the transmitter side, so that we get the original message. uh, although receiver tries to extract the message from the channel, but there are certain impairments that reside in that message, which are uh, which gives some sort of distortion or noise in the signal that we'll be discussing later in this lecture. Same as the transmitter, the receiver also comprises of a variety of subsystems and components like antenna, amplifier, demodulator, oscillator, amplifier, transducers, decoder, filter, and de-emphasizers. So it's actually collection of all those components. Sometimes you use a term which is named as transceiver. In some circuitry, we need to have a transceiver is actually a combined term for transmitter and receiver. So whenever we are using a device or a circuit where we incorporate both transmitter and receiver, so we call that thing as transceiver. So transceiver is an electrical unit that incorporates circuits that both send and receive the signal. A common example can be a telephone or computer modem or fax machine. So these are common examples. We can use a telephone to send the information or receive the information, both ways. So it's actually not the transmitter, not the receiver, is actually a transceiver, because it incorporates both aspects. And there are some counter examples as well, like the home television set is actually a receiver only circuitry, because it's not intended for transmitting any signal. Once the signal is received at the receiver side, it has to be delivered to the recipient or destination in the appropriate form. So generally it's converted back into the original waveform. For example, if it's a voice signal, it is fed into a loudspeaker so that the person can hear that voice. As I said, when the signal passes through a channel or a communication system, there are certain impairments which affect the signal propagation. So there are certain phenomena which degrades the overall performance of the communication system. So we want to discuss those phenomena as well. The first phenomena is actually called attenuation. Although attenuation is not does not degrade the overall performance, but it limits the overall communication distance. Actually, when we talk or we carry a signal to a longer distance, as the distance increases, the power of the signal goes down. So the word attenuation refers to the reduction of signal strength during transmission. So if you are like if you transmitted a signal which is carrying a 1 watt power, and if you observe a signal at a 1 kilometer distance, you would see that it would have a smaller power. Say for example, it would have a 0.1 watt power. But if you observe at 2 kilometer distance, you would see that the power would be further reduced. You may be getting a 0.0005 watts of power. So this loss of power is actually is named as attenuation. Attenuation happens in all types of system, but of course we do not want attenuation to happen, and we sometimes take some measure or amplification in order to reduce the effect of attenuation. Because of attenuation, the signal strength get reduced, and it becomes harder for receiver to detect any signal. Generally, attenuation determines how long, the maximum possible communication length between the transmitter and receiver. So, if attenuation is very high, in that case, the signal would go to a shorter distance. If attenuation is low, so you can carry the signal to even a longer distance. Although attenuation is a degrading performer, but phenomena, but it does not severely affect the signal because it only reduces the power, but it does not change the waveform shape. So, because signal is represented as a electrical or current waveform, so it does not change the shape of the waveform. Whereas we have other phenomena which are named as distortion, interference, and noise. All these phenomena, they actually change the shape of the waveform. The signal waveform shape or spectrum gets changed because of these three phenomena. So these three phenomena are actually considered more severe than the attenuation. One important point that I want to make, and you must have observed from the this block diagram as well, we have associated this noise, interference, and distortion phenomena with this transmission channel only. So we consider that the noise, interference, and distortion occurs in the channel only. Practically, all these phenomena can occur anywhere in the system, even in the transmitter, in the receiver or channel. So if it can occur at anywhere in the system, but it's a common practice to associate all these phenomena with the channel and considering transmitter and receiver to be an ideal entities that makes our signal our analysis more easier and more manageable. So as I said, these three phenomena, distortion, interference, and noise, they are more severe and they generally degrade the performance of communication system. So let us individually discuss these three phenomena. This diagram is kind of an illustration of three phenomena that I showed earlier. Say for example, this the first A diagram is our information signal, where we have represented bits, digital information, ones and zeros, by using a rectangular waveform. When distortion occurs, in that case, these waveforms, they deviate from ideal shape. So actually, the circuit that we are using, they are non-ideal in practical implementation. So that non-idealities in those circuits, they cause some changes in the waveform shape, and you can see that especially at the transition side, you see some shape change in the waveform. Interference is actually effect where we get some contamination from other sources. So eventually it also changes the shape, but it can change the shape at certain level depending on the interference level. Noise is also another phenomena which cause more rapid changes in the signal. So you can see that the changes are even more rapid in that noise as compared to the interference, and these changes are more kind of random, whereas interference is although it can be random as well, but it follows certain pattern. So what is distortion? Distortion is refers to the waveform perturbation or waveform changes which are caused by the imperfect response of the system. So because the system that we make in physical world, they have some non-idealities, so generally their response is not perfect. So eventually when the signal passes through that imperfect system, it causes some change in the waveform shape. And of course, if there is no signal, there will be no change in the shape. So distortion only happens whenever there is a signal in the system. If you switch off the signal, in that case there will be no distortion. In some cases we may be able to recover or compensate the distortion. So in some we have some special type of filters which are named as equalizers. These equalizers are used to compensate for distortion and try to recover the original waveform shape. This distortion also happens because of the non-ideal response of the transmission line or the communication channel and the circuit which are present inside the transmitter and the receiver. So this distortion occurs everywhere in the communication system. Okay, the second phenomena that we are interested in is interference. Interference is actually a contamination by some external source. Generally it comes from the human sources, but in some cases there are some natural sources as well. The interference occurs whenever there are more than one signals present in the same vicinity. Say for example, if two persons are communicating with in vicinity, so their signals, they kind of affect each other, and that affecting is named as interference. So because of that interference, generally the waveform shape gets changed because the signal gets changed by another signal which is present in the vicinity. This interference is more common in the radio communication system, radio systems or wireless systems, where antennas they capture different types of signal which are present in the free space. So because of the presence of all those signals, we get some sort of interference in our desired signal. So generally this radio interference in this radio system, it's named as radio frequency interference, because the radio frequencies, they gets interfered with each other, and these radio frequencies also affect the signals which goes through the cables. So bottom line is that the interference is actually a contamination or waveform change because of the presence of other signals in the vicinity, and those presence of other signals, it causes some sort of changes in the signal. To some extent we can have some filtering to remove the effect of interference. However, it cannot completely remove the interference. It can only remove the interference in a specific frequency band, but if you have some interferer in the same frequency band, in that case the filter will not be able to remove that interfering signals. Third, and perhaps the most important phenomena that affects the signal transmission, is noise. Actually noise remains in all type of communication system. As I said, distortion would disappear if the signal is switched off. Interference would disappear if there is no external source. You have an isolated wire which does not have any other source in the vicinity. In that case there will be no interference, but even in that case noise will be there. Noise is actually the internal response of the system. Internally, each system internally generates some randomnesses, and that randomnesses are named as noise. So noise refers to the random and unpredictable electrical signal produced by natural processes. Typically they are internal processes, but in some cases there are external processes as well. The most common phenomena that we encounter in the communication system is named as the thermal noise. So no matter what you do, there will be some sort of thermal noise available in that in a communication system. So what is thermal noise? you know, our communication system is basically an electronic circuitry. So it is made of some material. There will be a transmitter and the channel. They are made of certain material, and we know that the material has some electrons inside the material, which keeps on moving, and that movement of electron, it generates a random current, and that random current is actually named as the noise or thermal noise. And we know that if the temperature of the system increases, in that case the movement of electron would get faster, and we will get more noise in that case. So that's why we call it thermal noise, because it's dependent on the temperature of the system. So thermal noise is actually related to the thermal agitation of electrons in that communication system, which actually gets added to our desired signal, and eventually it makes harder to detect our signal. And if noise is too high, in that case we our signal can be totally obliterated, or if in some cases it can be partially corrupted. uh, the worst thing regarding noise is that we cannot eliminate noise by filtering. So there is no standard type of filter that can totally remove the noise. No matter what we do, there will be some factor of noise remain in the system, that will be available at the receiver side. One important thing that I want to mention here is that noise is not treated independently, because noise actually changes the signal shape, affect the signal which is propagating through the system. So how much noise is there, and how severe the effect of noise is, it is measured with relative to the information signal. So say for example, if we have an information signal of say for example 0.1 watt, and we have noise of 1 watt only, so in that case noise is higher than the signal, so we will not be getting the communication signal at the receiver side. But if we have a signal of say for example 1 watt and noise of say for example 0.0001 watt, so in that case the effect of noise would be negligible, because the noise is significantly smaller as compared to the signal. So the uh, treating noise independently does not make any sense. We have to consider noise in comparison to the signal strength. So the most common parameter that we use to represent noise is signal to noise ratio. So we calculate the power of the signal which is going through the system, and we calculate the power of noise, and we divide the signal power to the noise power, and this power ratio is named as signal to noise ratio, or simply we write it as SNR. So SNR is actually the true representation of how much severe the noise is in the system. So for any system we want to have as high as possible value of the SNR. So if we have high value of SNR, that means signal power is much higher than the noise power, so we can easily use that system to establish a good quality communication. But if SNR value is low, in that case noise power, it represents that noise power is very high. In that case we will not be having a good quality communication. So this is the main parameter that is used to represent the noise in a system. So these are three major phenomena which affect the propagation of the communication uh, uh, of the signal in a communication channel. Namely, we talked about distortion, is because of the imperfect response of the system; interference, which is because of the presence of external signals; and noise, which is because of the inherent thermal noise of the system, which affects the overall propagation. All three systems, they affect the waveform shape. As I illustrated in this diagram, you can see that in all cases, if you have distortion or interference and noise, in that case the waveform shape gets changed, and eventually all of these they lead to some loss of information. Okay, so this concludes our discussion related to the basic elements of the communication system. And while discussing those elements, we also talked about the degrading phenomena which exist in the system, and those phenomena, they tend to reduce the overall quality of communication systems. Generally, our communication systems, they are categorized in two types. One is called simplex communication. Second is called duplex communication. Simplex, the word simplex refers to the one-way communication, whereas duplex refers to two-way communication. Simplex communication means you can establish communication in one direction and there is no communication in the reverse direction. Say for example, TV broadcasting or radio broadcasting. For TV or radio broadcasting, the TV station can transmit signal to our TV sets, but we cannot, a home user cannot transmit signal back to the TV set. So it's only a simplex communication system where we are getting signals in only one direction. Sometimes we have two-way communication, which is named as full duplex communication, where we can establish communication simultaneously in two directions. For example, our cell phone or mobile or telephone, traditional telephones, we can talk and we can listen simultaneously. So we can have communication in both directions simultaneously. There is a third type of communication as well, which is called half duplex communication. Half duplex communication is also a form of two-way communication, but in that type of communication systems we can have only one party transmitting at a time. So it's not simultaneous communication. Rather, one party communicates, it ends the communication, and then the other party would be able to communicate. If two persons start communicating simultaneously, in that case nobody would be able to hear anything. So the example is a walkie-talkie that is used for generally the security services. So one person talks at one end. When it finishes, his comment just says over, and the other person starts talking. So it's the same system used for two-way communication, but only one party can talk at a time. So these are two major classification of communication systems. Of course, most of the communication system that we'll be discussing in this lecture is full duplex communication, because all other, they are actually subcategories of this full duplex communication systems. So so far we have talked about the communication systems. Before starting our next topic, I want to briefly review regarding the electromagnetic spectrum, and I understand that you have already studied the course of electromagnetics, so we would quickly review some basic concepts related to electromagnetic spectrum. Actually, electromagnetic spectrum is generally represented in terms of frequencies. So this range of frequencies is named as electromagnetic spectrum. For convenience or for representation, we have divided that spectrum into a smaller bands. For example, 30 to 300 hertz band is named as extremely low frequencies. 300 hertz to 3 kilohertz band is named as uh, very low frequencies, and so on, low frequencies, and we move forward to uh, millimeter waves and infrared and ultraviolet frequencies. We know that electromagnetic waves, they have certain frequency as well as they have the wavelength. At the top here you can see that there is wavelength, and you can see that if we increases the frequency, the wavelength gets decreases. So wavelength is actually increasing in this direction, and frequency is increasing in this direction. This is the band which is named as radio waves, which is used for wireless communication systems. There are two important things related to electromagnetic wave. One is its frequency and second is wavelength. I hope you already understand that the frequency is actually the number of cycle of repetitive waves that occurs in a given period of time. So this is the illustration of the cycle. So one cycle for a sinusoidal wave, it comprises of a positive alteration and a negative alteration. This becomes a one. This is the one cycle. So how many times this cycle is completed in a second is named as the frequency of the wave. So this would be represented as cycles per second, but this unit has been renamed as hertz. So we measure the frequency as hertz. Second is the wavelength. The wavelength is represented by this Greek letter lambda. The wavelength is actually the distance occupied by one cycle of the wave, and of course, as it's a distance, so it should be measured in meters. So this is an illustration of wave. If you consider one complete cycle like illustrated here, so this is one wavelength. It does not matter where you start the signal. So if you start the cycle from this point, so this would become again one wavelength. So if you complete one cycle, the distance would become equal to one wavelength. There is a simple relationship between wavelength and frequency of electromagnetic wave, and this relationship is represented by this simple formula: C is equal to F lambda. F is the frequency of the wave, lambda is the wavelength of the wave, and C is the speed of light. Actually, the electromagnetic wave propagates in free space with the speed of light. So the wavelength the electromagnetic wave satisfies this formula, that it's whenever we multiply the frequency and wavelength, we get a constant which is equal to the speed of light. So using this formula, C is equal to F lambda, we can calculate the wavelength or frequency of any wave. If frequency is given, you can calculate the wavelength, or vice versa. So this is an illustration of application that we use in communication systems. So at the left side, this diagram represents a wavelength, and at the right side, this diagram represents the frequencies. And for each frequency, these illustrations, they show the band of the spectrum that we have, and the type of medium that is used in that particular band. Generally at low frequencies we use the copper wires. At relatively higher frequencies we use coaxial cables or free space communication. At even higher frequencies we need to use free space or waveguides, and at even higher frequencies we have to use optical fibers. And type of propagation that is needed in that particular type of medium is also illustrated here, and different applications which used in that particular frequency band are also listed here. And you can see that different applications, they are assigned different frequencies for their use. So AM broadcasting is done at even lower frequencies, whereas wireless communication is done at relatively higher frequencies of the order of gigahertz. and the satellite communication, uh, uh, they are used at even higher frequencies and so on. So I would strongly encourage you to take a look at this chart, so that you get a basic idea of what type of transmission media we use for what type of frequencies, what type of application. So I would conclude my lecture here. In this lecture we have discussed some fundamental concepts related to the communication system, discussed the elements of communication systems, system that is used to transmit the information through the system. So thank you all.